of this series. Let us see the C programming code for creating a node structure. Here we have included the header files. So header file for memory allocation and deallocation, which we include, is stdlib.h and stdio.h. Okay. So we have to include these header files in our C program. Then we have declared a structure, struct node of name node, to create a structure like this node which has two parts, the info part and the pointer part, and the structure will have two elements in it, two members. First is an integer, which is an integer info. Info is an integer, so it will store an integer value. So any number can be stored here, 1, 2, 50, 78. Okay. And it is pointing to there is a pointer ptr which is of type struct node, so it is pointing to another node of same type, which is a struct node. So it is called as a self-referential structure, a structure in which there is a pointer to a same type, okay, that points to itself, okay, which points to a data type which is its own data type. Okay, so here the pointer is of type struct node, so this structure is called as a self-referential structure. So here we have completed our definition of structure. It contains two fields, info and the ptr, that is a pointer. So this is a pictorial representation. Info is a field where we store integer data, and pointer is a field where we store the address of the next node. Okay, so here we have declared struct node start, pointer start, then pointer temp, pointer q, pointer r. So these pointers are helpful to create a single linked list. So start, we know start is a pointer which denotes the very first node of the list. Temp we will use for the various operations like insertion, deletion. We'll temporarily create a node and we'll add it into the list, or to manipulate list will require temp. Okay. For searching and for moving through a list, we'll use pointer q and r. Okay, it will help us in deletion and insertion operations. Okay. So after this line, we can create a node with this structure, which contains two parts: the info part, which is an integer, and ptr, which is a pointer which points to another node of type node. Okay, so it is a self-referential structure. Then this line of the code is very important. So this is nothing but the memory allocation at runtime. So when this line will be executed, so it contains the at this point it contains a pointer variable temp. So temp will have a memory address of the first location of the whatever memory allocated by this malloc function. So I already told you that for dynamic memory allocation at runtime, malloc function is used. Here we are using malloc function. So malloc function takes the argument of how much size of memory we should allocate. So that size should be equal to the size of the node. Hence we have passed a parameter which is nothing but size of struct node star. So this parameter is nothing but the how much size this node structure will require to be stored in memory. That much size will be allocated to this temp pointer or temp variable. Okay. Now once this temp variable is allocated with memory with malloc function, the structure will look like this. So temp is now our node, temporary node. Let us say it is allocated with a address 1000 for this first part, that is info part, and 1002 for the pointer part. So our temp will contain the address of the first part, that is a 1000. So temp will be 1000, and this node structure will be created with the help of this line of code. Now next step is to fill this info part with some data. So how to fill here a data? So we'll ask user with the help of this printf and scanf statement, we'll ask user for enter data. So user will enter the data and will scan that data with this scanf function, and see here you can take, we are taking a percentage d, means it will be integer value, and will store at the info part of the temp variable. So this is a temp variable, so we'll store, let us say user entered 10, so that 10 will go in the info part of the temp. Okay, so info part of this temp, so 10 is stored here, and we'll make the pointer field, because it is just a single node, so the pointer field will not point to anybody else, so we'll temp arrow ptr, so this pointer field will set to a value null. So this arrow operator is used to access the individual data member of this structure. So to access info, we are using the syntax temp arrow info, so we'll access the first field, temp arrow ptr will access the second field, likewise. Now to create very first node of the list, we have to have these two lines of code. We have to check whether start is initialized or not, or whether it is null. So if its start is null, so nothing is there in the list. So we'll check first whether start is equal to null. If it is null, means nothing in the list, so we'll initialize start equal to temp. So whatever is there in the temp variable, now will that same value will be pointed by the start. So this is our start pointer that we have created globally. Now it will point to a temp. So temp contains address 1000 as we see in previous slide. So temp is having address of 1000. That will be pointed by start also. So it will be stored in the variable pointer variable start. So start will now point to the 1000. So this becomes our single element in the single linked list. So this will be our first element in the single linked list, and we know that start or head will always point to the first node of the list. So now this value 10 becomes our first node in the single linked list. Here we have the info part has a value 10 and the ptr part which is null, so it is not pointing to anything else. So this is a single linked list with a single node, and the start is pointing to the first node. Here for this null we can have this syntax also. We are grounding like this, so this grounding symbol is nothing but it is the same as that of the null value. Okay, so this was the basics of C program to write single linked list code.